Hello everyone. In first four chapters, rather in the first four units, we have discussed topics based on statics. We have learned situations where the object or the body which is in study is at rest. It is not moving. Now in unit number 5 and 6, we will consider situations where the object will be the body which is under study is in motion. So that part of the engineering mechanics is referred as dynamics, where the body will be always in motion. The branch dynamics of mechanics is further divided in two sub-branches, kinematics and kinetics. In kinematics, we are going to study purely only the motion of the body. We are not going to consider how much is the weight of the body or what are the forces applied on the body while the object is or the body is in motion. So we are purely going to study only motion of the body in kinematics. That means we are going to study parameters of motion like displacement, velocity, acceleration, time of travel. Only such parameters of motion are going to be considered. We are never going to study uh, how much was the weight or mass of the body and forces applied or generated during the motion of the object. So that branch is called kinematics. Whereas if we consider parameters of motion as well as the mass or weight of the body and the forces applied on it, such branch of dynamics is called kinetics. So we need to understand the difference between kinematics and kinetics very clearly. I hope you have understood this. Now let's begin with unit number 5, which has kinematics of particle. There are two chapters. First is rectilinear motion and the second is curvilinear motion. Let's begin with chapter first, rectilinear motion. As the name suggests, motion of a particle along a straight line path is referred as rectilinear motion. So if a particle, now what is particle? We know that in engineering mechanics we have assumed in many cases the object has a point mass. Let's say the size and shape of the object is neglected and its entire weight is assumed to be concentrated at a single point. That single point object is called a particle. So we are assuming that such object which is considered a particle is going to move along a straight line path, and the study of such motion is called rectilinear motion. There are three types of rectilinear motion which we can rather we are going to study in this chapter. Variable acceleration motion, the second is uniform velocity motion, and the third one is uniform acceleration motion. Starting with variable acceleration motion. Acceleration of the particle while it is moving on a straight line path, if it keeps on changing, such motion of the body is called variable acceleration motion. It is called VAM. So here as we are saying, there will be change in the acceleration of the body, and we are going to study that change in acceleration either with respect to time or with respect to velocity or with respect to displacement. What exactly we mean by this? Either we will be given a relation where we will understand or we will come to know how the acceleration is going to change as we change the time. So there will be equation in which either acceleration and time will be there, or we will have equation where relation between acceleration and velocity will be there, so that if the velocity changes, how the acceleration is going to change, that can be understood. Or similarly, we can have a relation between displacement and acceleration. So we can have different equations where dependency of acceleration will be either on time or velocity or displacement. So acceleration can be function of time, acceleration can be function of velocity, and acceleration can also be function of displacement. All the symbols have their usual meaning. S or x represents displacement only. Right, let's go further. For solving numericals of variable acceleration motion, we are going to use basic expressions, or let's say basic definitions of velocity acceleration. We know velocity is nothing but rate of change of position or rate of change of displacement. How fast the particle is changing its position, that is called velocity. So v is the velocity is can be represented as dx by dt. Either you call it x or s, both mean the same thing. Both represent the position or displacement. Position and displacement both mean the same thing. So velocity is rate of change of position, that is dx by dt or ds by dt. Then similarly, you know, acceleration can be called a rate of change of velocity. How fast the velocity of the object is changing, that is nothing but acceleration. So dv by dt is expression, or let's say definition of acceleration, and we are going to use these expressions for solving numericals. There is one more expression for acceleration which we can generate from the same expression, acceleration equals to dv by dt, by applying chain rule. Acceleration is v dv by dx. Let's say if I write as dv by dx into dx by dt. This is nothing but application of chain rule here. Dv by dx into dx by dt. We know that dx by dt is nothing but velocity. So v into dv by dx, that is nothing but acceleration itself, right? So whatever expression we have got here for acceleration, v dv by dx, we have derived it from the same expression of acceleration as dv by dt, right? Moving ahead, now with this particular information, these are the basic definitions or the expressions we need to know for acceleration and velocity, and using this expression itself we are going to solve all the numericals for particularly variable acceleration motion. Okay, so remember, in variable acceleration motion, the acceleration keeps on changing with change either in time or in velocity or in displacement. Let's see. Now you can of course pause the given video and read the given question carefully, and after that you can start solving it. I'll recommend that you need to understand the given question well, and then only you can solve it. So make a habit of reading the question carefully all the time. So the given data in the question is one equation where x, that is displacement, is given as a function of time. So here we have expression of x and t, a relation between x and t, displacement and time. And in the question we are asked to find out time at which velocity becomes 0. That means when velocity is equals to 0, how much is time t? And another thing, determine velocity and acceleration at t equals to 5 seconds. So at t equals to 5 seconds, what is the velocity and what is the acceleration? We are asked to find velocity and acceleration, but the equation that we have is of displacement, which is in terms of time t. So we need to convert this equation of displacement into equations of velocity and equations of acceleration, and then only we can find out the required things. So how do we follow this? How do we generate the equations from the given equation of displacement to equation of velocity and acceleration? We know we are going to use basic definitions of velocity and acceleration for doing so. As we know, velocity is rate of change of position or rate of change of displacement, that is dx by dt. If I differentiate the given equation of displacement with respect to time t, dx by dt is going to give me velocity. So I have done that, and equation 2 is our required equation. Further, if I differentiate the equation of velocity, that is again with respect to time t only, that is going to give me dv by dt, which will be acceleration. And then Once we have got the equations of velocity and acceleration, the required things can be calculated. The first sub question, when velocity is equals to 0 meter per second, how much is the time t? I hope you are comfortable with differentiating these equations with respect to time t, which is a very trivial job. So all of you must be confident while doing so. Let's see. Now, once we have got the equations of velocity and acceleration, we are asked to find out at what time t velocity becomes 0. So in the equation of velocity, which is equation number 2, let's substitute v is equals to 0, because we want to find out time t when velocity of the particle becomes 0. So assuming v is equals to 0, let's solve this quadratic equation. Of course, the entire equation further can be divided by 3, because each term here in this quadratic equation is a multiplier of 3. So you can divide the entire equation by 3. Still, you are going to have the same answers. Because it is a quadratic equation, I hope you can solve quadratic equations on calculator, and you'll get 2 answers. None of those 2 answers is negative. So of course both are going to be our valid answers. What does that mean? Velocity of the particle is going to become 0 at 2 different instances. First, the particle is going to stop at t equals to 1 second, and after that at t equals to 3 seconds also the velocity of the particle is becoming 0. So both these values are our valid answers. Further, let's try to find out the second. Let's solve the second sub question. At t equals to 5 seconds, how much is the velocity and how much is the acceleration? So now by this time you might have guessed that whatever equations of velocity and acceleration we have generated, equation 2 and 3, in these two equations we are going to substitute our required time t, or the given time t, which is 5 seconds, and then we are going to reach to our answers. Don't forget to write down the units for the quantities whatever you are calculating. So velocity at t equals to 5 seconds comes out 24 meter per second after substituting in equation number 2, and by substituting t equals to 5 in equation number 3, the acceleration comes out 18 meter per second. That's all. We'll come up with one more type in variable acceleration motion in the next class. Thank you.